Hi, my name is Caitlin Holm and I work with the Polk County Land and Water Resources Department, and today I'm going to show you how to use a probe that we purchased with assistance through a Wisconsin DNR grant that will measure temperature and dissolved oxygen in the lake. So the first thing that you want to do is go to the deepest part of whatever lake you want to take your sample on, and you can find that information online and use the GPS to get there. And then once you are where you think you should be, you'll want to use a depth finder to make sure you are at the depth that you think you're at. So I've got a handheld depth finder used to take a depth, and right here it's 8.5 feet deep. Next thing that you're going to want to always have when you're out in the field is a notebook and a writing utensil. You can see we have a Write in the Rain waterproof paper notepad, and you're always going to want to record key information like the date, who's out sampling, the time, in addition to any data that you collect. The first thing that you want to do is turn the meter on, and there's a big green button on there that you just press and hold, and then wait for the meter to come on. And you're going to want to pull off the piece on the end, and there is a little yellow sponge in there that you want to make sure stays in there and that it stays moist. And you'll lower that probe into the water just at the surface and wait for the meter to stabilize, and it could take a few seconds. So right now it's jumping around, and the meter does have 4 different readings that it's giving you, and you're going to want to record the first one, which is the temperature in degrees Celsius, and then the last one, which is dissolved oxygen, and the units are milligrams per liter. And those are things that you're going to want to make sure you record in your notebook, just what the units are. So right now it's stabilized at the surface at 10.6 degrees Celsius, so we'd write that down in our book. And the DO, the dissolved oxygen, is at 9.51 milligrams per liter. And you'll want to write that at a depth of 0. And then the next thing, the meter's marked off in meters, so you're going to want to lower the probe down to that first yellow marking for 1 meter. And let it stabilize again. And it's already stabilized, so for here you'd have a depth of 1 meter, a temperature of 10.4 degrees centigrade, and then a DO, or dissolved oxygen, of 9.61 milligrams per liter. I think on this lake we're usually able to get about 3 samples, so we'll go down to our second meter. And of course, I'm not writing this down, but you're going to want to make sure you're recording all of these values. Let it stabilize again. And right here at our second meter down, we're at 10.2 degrees centigrade and 9.49 milligram per liter dissolved oxygen. And here we've hit the bottom. So you can tell that when you have slack in your line and you haven't yet reached your next meter mark. So that would be it for this lake. So maybe you're wondering why it's important that we collect this data like temperature and dissolved oxygen, and it is very important because it does give us a better picture of what's going on in our lake, and especially if you're already doing citizen lake monitoring on your lake where you're collecting information like phosphorus, chlorophyll, and Secchi disc. This information regarding temperature and dissolved oxygen can just paint a better picture of what's going on in your lake. Dissolved oxygen is obviously very important for the aquatic organisms that live in a lake, and especially in shallow lakes like the one we're on today, you can sometimes see a drop in dissolved oxygen as you get to the bottom of the lake. And that's important to know because it has a lot to do with the cycling of nutrients such as phosphorus in a water body. Temperature is important as well, and it'll help us know if a lake is stratifying or not, which is a really important bit of information to have. And you can tell that by looking at the temperature profile of a lake as you go down towards the bottom and how that compares with the temperature towards the top of the lake.
Hi, my name is Jeremy Williamson. I am a water quality specialist at the Polk County Land and Water Resources Department in Balsam Lake. Another piece of equipment we have for volunteer use in assisting with lake management is this Swiss-made flow meter. And this tells you the feet per second that a particular tributary would be moving. So for example, we're on the Straight River here in between two lakes. This one also tells you the temperature, and it averages the flow for you. So as you can see, it's a propeller driven flow meter. In order to do this properly, it's nice to have a couple of people. We string a tape measure across the stream, and we take a reading every foot and record the depth as well. That way, when you get your chemical samples back, if you are indeed taking chemistry samples, you can get an idea of what the loading is, because you have a volume of water and you'll have this velocity from a particular stream to a lake. So it's not very difficult to use. Easiest way to do it, measure the depth, meter stick should be fine. Go down, and right here we're at about 24 inches. And what you want to do is put the propeller about 60% of the way down. So you want to go just over 12 inches and take a reading. You don't want to go all the way close to the bottom, and you don't want to be too near the top because there's a little bit of drag in the stream. So what we're getting here, when I'm looking at it, is we're at about 0.8 feet per second. The water is about 10 degrees centigrade. So we would write that down in a notebook at whatever distance you're at from the bank, and then you move on to the next foot. So if we move to the next foot here, we're at about 25 inches, so we're really close to where we were before. You go back down around 12, and we're at about 0.6 feet per second. It bounces around a little bit. You know, as the stream bottom changes, as you move through, there'll be rocks and twigs and sticks and things. There's no need to move them out of the way, because that certainly changes the current of the water. And then when you're done recording, if you do this over the course of a season, you'll have an idea of each tributary and what it's contributing to your lake. Generally, we're looking at phosphorus once again. A third piece of equipment we have for volunteer use is a GPS unit. Generally, if you're going to multiple sites, it's imperative that we know what's attached to what site. So, as you can see, it's fairly simple. Power button is the red button. There's a menu, so you can manage the points you take. You can go to different maps. You can look at, there's a compass. A lot of different features. Generally, we're just using it to take what are called waypoints, just a point. To do that, you simply hit enter and hold it, and you can see here's your point, your latitude and longitude. It does give you your elevation if you so desire. So you can either write that down in a notebook, or it is pretty easy to label it. You just use the arrow buttons, go up, hit enter to change anything, and you can just go to the letters of the alphabet and label what you want. So this is Straight River, so go to S, R, we'll change that to 1, go to done, hit enter, and now you have a site on your map.
As I had already mentioned, all of this equipment was purchased by the Polk County Land and Water Resources Department with the support of a Wisconsin DNR grant. And if you are interested in using either the probe to measure dissolved oxygen and temperature, the flow meter to measure flow, or the handheld GPS to track your location, just feel free to give us a call at 715 485-8699, or you can look up the Polk County Land and Water Resources Department on the Polk County website to access our contact information there. One last thing that I did want to mention is that there is a Wisconsin DNR database called SWIMS, and that is a database where volunteers can enter in all of the data that they've collected.